Lesson 6.6, find angles given reference degrees / radians. So this is kind of an intro to now switching our brains from always dealing with degrees to what is the radian measurement of the angle. And remember, we talked about, or we've learned that this is a 0, pi. This is pi. So 180 degrees equals pi. All the way around would be 2 pi. But we always think of everything out of a total pi, which is actually a half a circle. Kind of weird. And so I wanted to go back to just fractions, adding and subtracting fractions. This is pi over, I could put it over 1 plus pi over 6. You cannot add fractions unless you have a common denominator. So I would both have to make them both be out of 6. And so this, 1 times 6 would make 6, so I'd have to take this times 6. So what my brain really does is think, what's 1 whole pi? If I wanted it something out of 6, that would be 6 makes 1 whole. And so then I would add 6 pi plus 1 pi makes 6 pi. You keep the denominator the same. Okay, so the next one is having pi over 6, a 6, plus a total of 2 pi. So if this is over 1, think about if I want to make these common denominators of 6, I would have to take this times 6, this 2 pi times 6 is 12 pi. And so you're thinking, what's 2 whole pies if they're in 6 pieces each? That would be 12 6, or 12 divided by 6 makes 2. So that would become 13 pi over 6. And then the last would be subtraction. Let's see if we can do it without really much math. If I think this is a half pi, or pi over 2, I want to think what 2 over what would make 2? Well, I'd just basically double this. That would be a 4 halves, right? 4 pi over 2. I'm just taking times 2 times 2. So it's 4 pi over 2 minus pi over 2. 4 minus 1 would be 3 pi over 2. Okay, but anywho, that's just kind of a preview of now what we're doing. They're going to say if sine of theta equals square root of 2 over 2. So some angle gives us a sine value. The reference angle of theta is 45 degrees. I like this because it tells you part of the answer. Find both angles in degrees from 0 to 360 and both angles in radians from 0 to 2 pi. So we don't really even need to know what sine of square root of 2 over 2 is. It's 45 degrees. This is a positive value here. So sine is positive in quadrants 1 and 2, where the y's are up. And so in quadrant 1, this would be our 45. That helps you. And then quadrant 2 would be our 45 degree from a 180. So 180 minus 45 is 135. But the harder thing for us to do is now turn it into radians. So think about 45 degrees is what part out of 180 degrees? How many 45s does it take? Right? 45 doubled is a 90, and 90 doubled is a 180, so this is 1/4, or pi over 4. And you'll kind of get that memorized, but pi over 4 is a 45. And then so a 135 is thinking from here, a 180, or pi minus a pi over 4. So this whole is really 4 pi over 4 minus pi over 4. 4 minus 1 is 3 pi over 4. If that's hard, you can look at here, and we do have those on the circle as well. Right, number 5. If cosine of theta is negative square root of 3 over 2, they're telling us the reference angle of that is a 30. Find both angles in degrees and radians. So let's think about, where is a cosine negative? That would be x values are negative here and here, quadrant 2 and 3. So I want a 30 degree reference angle. 30 degrees back from a 180 is 150. And 30 degrees past a 180 is 210. But now you want to know what those radians are. Oh, I put that in the wrong spot. Whoops. Sorry. Okay, so 150 would be taking like a pi minus a 30.
Teacher, sorry for the interruption, but I need to see all.
A pi minus, let's see, 30 degrees. Think about what part of 180 that is. That would be a 1/6, so it's pi over 6, and that's on our unit circle. So it's taking like pi minus pi over 6, or 6/6 minus 1/6 would be 5/6. Okay, and then a 210 is taking pi plus our 30-degree reference angle of pi over 6. That would be 6/6 plus a 6, which is 7/6. But again, if you need to look at the circle, they're on there. There's the 5 pi over 6, there's the 7 pi over 6. But try to get your brain thinking about these parts. If cotangent of theta, so this is our first reference angle we have, is negative square root of 3 over 3, and the angle of that is 60, find both angles in degrees and radians. So you could change this into tangent if you wanted to. Still be a negative. We'd flip it and have, what, 3 over square root of 3, but we'd rationalize, and you get your 3's to cancel. That would actually be this. And so we do know that that is a 60-degree reference angle. And tangent is, and cotangent is negative in quadrants 2 and 4. So in quadrant 2, we would do 180 minus 60. In quadrant 4, we do 360 minus 60. So we would get in degrees a 120 and a 300. And then in radians, I want to think about 60. What part is 60 out of a total 180? That'd be a third. So pi over 3 is what I'm using. So this would be taking pi minus pi over 3, which that would be 3/3 minus a third, which is 2 pi over 3. And then this one would be taking 2 pi minus our pi over 3. And then that would become, what, times 3 would be 6 pi over 3 minus 1/3. Pi over 3, that would be 5/3. So the good thing is you have the same denominator. Now the other thing, if you're just totally lost with the fractions, I would suggest doing this all in degrees and then just turning these degrees into radians. So I could take 120 degrees times, remember the ratio of, you want your degrees down here with pi on top. So basically you're just simplifying 120 over 180. Cancel the zeros, take out a 3, no, it was 6. So that would be a 2/3, and then tag your pi in the numerator. So maybe that's faster as well. Up to you.